Hey, good afternoon. Welcome. Jeff Wilson here from Atlantic, Canada, National Vice President of Business Development for Stonehard. Just a quick introduction. I've been around about 30 years doing this work and have learned a lot of things not to do. I hope to put some of that into this presentation. We're going to start off with a small video and a couple of slides, and then we'll get this thing going. Thanks a lot for joining into the seminar. Well, again, welcome. I hope you enjoyed the video. We're going to today talk a lot about resinous floors, walls, performance, and application, of course. This is a course that was developed in the United States, conjunction with our US team, and it's a passport course, so it's applicable here in Canada. It's a great course, and we'll talk a lot about, the actual installation, quality control, and those sorts of things, and design improvements and such that have taken place over the last number of years. We're going to spend a couple of slides on Stoneheart, and then we're going to get right into the meat and potatoes of the presentation. So Stoneheart has been around for about 100 years. I'm here for 30 of those. We're a little bit different. We're a one-source turnkey operation where we manufacture the materials and we engineer the installation and control the installation, and then provide a single source warranty to you or your customer. We have many assets around the world. Here in Canada, probably 40 or 50 territory managers, number of construction management team, and a lot of installation teams as well. So when you look at our size, we do about 5 million square feet a month here in around the globe, and we manage over 6,000 projects a year, and 95% of our customers are repeat. One of the best parts about Stoneheart is because we handle the installations, we get to take that information and get it back to the product designers. So our products are tested in the field and tweaked in order to make a product adjustment for field application, which is very unique in the industry and something that has taught me a lot over many, many years. So the learning objectives basically is resinous flooring products, application, and solutions. So how we decide, how we do design criteria, that sort of thing. And then we're going to look at typical finishes and costs, and then quality control for successful installations, things that you might be able to put in a specification to guarantee you get what you need. And then at the end, we'll have some discussion time. You are able to send me a chat at any time during this presentation, and I'm happy to be able to try and answer those as we move through this presentation. I'm just going to say it's my first virtual presentation, so I'm a little more animated than most. So I just want to kind of give everybody a heads up that this will be my first. So hopefully you enjoy it. We can I can teach you something about what I've learned. So some of the markets that we look at, one of them is the industrial markets. Here in Atlantic Canada, pulp and paper, mining, those sorts of things, but pharma, biotech, food and beverage, big one. You can read the slide, general manufacturing. One of the unique things about us is that's where we really cut our teeth in resin development. And it was this, this market that really gave us the edge when it comes to commercial markets with our chemical resistance, our slip resistance, and that sort of thing, and transferring that into the commercial markets to increase the longevity of most of our systems. As I said, the other commercial markets, healthcare, education, hospitality, government, prisons, those sorts of things. And as I said, with 6 million square feet a month globally, we can provide a lot of history here over the last number of years. I mean, I have plenty of floors that have been in service in some of these commercial locations for over 30 years. So it's a real testament to the ability to get the right product specified in the right area. And that's where Stonehard, or that's where we really shine in terms of trying to make sure that we get the design criteria correct for you. So let's talk about the traditional, flooring products, from terrazzo, sheet vinyl, rubber, those sorts of things. That's the traditional materials that you've seen. We generally, our solutions are cast in place polymetric materials to protect and restore and enhance a concrete slab or other substrates. Three basic chemistries that we use is epoxy, urethanes, and MMA chemistries, which is methyl methacrylate. All of these, of course, have a number of different tweaks and those sorts of things in the chemistries to make them do different things. But in general, they're all organic materials. We hear a lot about different, miracle products. And, every time you go and tweak a chemistry, there's a yin and a yang. So if I increase the chemical resistance, I might reduce the working performance for the field. Whatever we do, there's always a rebound to it. So one of the questions is, why would you go with resinous floors? I mean, there's a number of benefits to a seamless floor system. And seamless, as I mentioned, hygienic, easier to maintain, and easier to clean. In this day of COVID-19 and infectious control, seamless surfaces are going to become more and more important. And as you have those seamless systems, and you might even add an antimicrobial to the surface, you're also going to use more aggressive cleaning materials. So chemical resistance is going to be important. If you're going to scrub the floor, abrasion resistance and impact resistance, all of these things add to a longer life cycle. And then as you get to more cleaning, that means you're going to have wetter floors. You need slip resistance for safe work environments. These are the kind of things that a good partner will help you walk through as you just start to design your system for the usage that's important to you. Couple of nice little pictures here: sterile, stain resistant, and easy to clean versus a chemical and impact. So the left screen is more of a commercial product, and on the right screen more of an industrial product. But as we cross over these marketplaces, we start to take some of the chemical characteristics of the industrial and move them into the commercial aspect. And this is really important because it's going to be that kind of advice that you really need as you build a system for the given conditions for which you are specifying and or installing. So design freedom and flexibility is really important. Custom colors versus standard colors, different finishing options. We have systems now where you can kind of pour the floor in place, and you need the designer with you as you customize the way it looks. You can look at logos and those sorts of things, different textures in walkways versus under equipment, or those sorts of things are all part of the design freedom and flexibility. It's not out of the package. It allows you to be much more creative in your designs. So the poured in place floors, as I mentioned, are part of a building structure. So in this particular picture, you see the reflectivity of this, the automobile on a very shiny floor. So that floor becomes part of the structure. Once we prepare the floor and it gets a good bonding material, that becomes part of the floor. We use low VOC products, 100% solid epoxy, water-based, urethanes, rapid renewable materials. We use recycled materials like crushed glass, rubber, those sorts of things. And all of these things can assist with your LEED credits or your credits for durable building. The HPDS available, that's really a US-based thing and not for Canada, but certainly if anybody's got any questions about that, I had to Google that actually to make sure I understood what that was. Not something we see in Canada, but like everybody, I learn every day, and that's something I learned today. As I mentioned, the design flexibility, you can really be inspired to make some really nice designs. In this particular case, you can see the different colored floor systems and such separated by a terrazzo strip. And these things are really important to give you that design criteria. You might want a very light floor in some areas, but in the traffic areas, you might want a little bit of a darker finish for easier cleaning or vice versa. These resinous systems really give you an opportunity to design the space that you like. When it says individuality, we've done a lot of custom applications. In this case, you see, antique cars and those sorts of things. So the designer and the owner working together and then requesting the resin supplier to come up with a system that meets the criteria for which their particular operations. One of the things that we worry about in garages, any garage, that sort of stuff, is tire marks. Tire marks, like very simple, would seem quite simple. But if they happen to go in here and start spraying Armor all on the tires and they start doing cleanups and touch-ups, you never know what residual will get off the tire and onto the floor. And then you got to make sure that your flooring is prepared for that. One of the antidotes I always use is to drive your car into a garage after you've been down on the Autobahn and your tires are hot. And when you move the car, bang, off, it vulcanizes the tire right to the floor. So you can have a real pull-off issue. So these are things you have to be considered, but it does allow for complete, individually designed. Some very nice space here. You can see the designs in the floor. So, a good coatings person can come in and work with you and understand your needs, your design criteria, and, your imagination is the limit to what can happen when you're working with someone with some experience. So let's talk about balancing safety and cleanability. If I had a self-cleaning, anti-slip, white floor, boy, I would have retired years ago. You can't have 100% cleanability and 100% slip resistance all at the same time. You can do a pretty good job by adjusting the amount of texture in the surface. So as you see here on this page, you see the system type called mortar system and coatings. So it goes down through a texture system, texture level, no texture, 1, 2, 3, 4, 5. And then it has the material properties. So as you increase your texture, you can see in the cleaning methods that, with no texture, you can basically a damp mop, maybe some mechanical cleaning. But as you increase that texture, you might have to go to a power wash or a bristle brush or that sort of thing. So a good rule of thumb is to make sure that you always get your cleaning people involved in the texture selection and operations. So this is always a good thing to make sure that everybody understands what they're purchasing, because it is far easier to reduce texture than it is to increase texture after you've installed the floor. So if you have a slip fall issue, you basically have to redo the floor if you want to increase the texture. However, if you have too much texture and it's a cleaning issue, you can increase the amount of resin on the surface to take away some of the texture. So it's a pretty important part of the selection process. We've got decorative mortars, and then we've got flake broadcast system. When I look at these flake broadcast systems, they look nice, they're easy to install, but boy, are they slippery. So, I'm always talking to people about, we see a quartz broadcast system versus a flake broadcast, and, they say, oh, they're the same, and really they are not. And, I kind of see those being put in places that probably I would not recommend. But again, that's why you have a good coatings person to help you go through that. In a quartz broadcast system, you have the ability to put some texture. We do this in operating rooms and hospitality industry where possibly you need a very durable floor, but you also need it to be very safe and slip resistance, and infectious control needs to take place. So it's always that balance, and certainly we have, most companies will be able to provide you with a number of different samples to pick that selection. When it comes down to resin options, I spent a significant portion of my career traveling around the world, looking at different resin systems and seeing which ones we could bring back to Canada and that are created at one of our operating sister companies in, Europe or Africa or what have you. And we were always looking for, that magic, that opportunity to have a product or have an offering that was unique in the marketplace that solved a lot of problems. And one thing that I have learned over my 30 years is there is no magic. There is only excellent engineering support and engineered coatings. So when it comes to resin options, here we say epoxy, urethanes, and acrylic/MMA. There are polyesters and vinyl esters and those sorts of things as well. And we have all those. But there, each one of those, comes with other limitations. And but just to give you the three basic, uses, you've got epoxy, urethane, and MMA. Well, the epoxy, the cure time is 12 hours, urethane 6, and MMA 1. Well, there is an argument there as to just why would you have it all at 1 hour? Well, a lot of times you design a system so that it cures at a slower rate to really penetrate the concrete, to get a good mechanical bond to the concrete. So the epoxy's been designed that way. We can make them cure faster if we'd like. Urethanes, when we go to do a urethane floor, it's got slightly higher viscosity and resin content. So 6 hours was the optimal cure. The acrylics or MMAs were an hour. Well, that hour does not allow a lot of time for the materials to soak into the concrete or substrate. But it can be installed in a lower temperature. It's got some other benefits to that. So in that case, one of the things that are really a problem with an MMA is it smells so bad. So you have to really evacuate the area. Whereas epoxies and urethanes, they use different materials, but they're very, very low odor, almost zero. And their abilities to handle different things are good. If you'll notice, the epoxies, the heat limitation is about 160, and the heat limitation on a urethane is about 250. Well, it's not so much the ability to handle the high heat, it's more the ability to handle the change in heat. So epoxies generally don't react well to a huge spike in temperature, whereas the urethane can handle that very easily. So again, having a good partner to explain those differences is really critical when you're looking at different resin options and understanding the costs, the benefits, and the downsides of each one of these selections. So as it goes for system configurations, each one of these resin systems has the ability to be part of any one of these configurations. So epoxy coatings or MMA coatings or urethane coatings, high builds or broadcast or troweled or those sorts of things, any of those resins can be used for these system configurations. And there's a lot of confusion in the marketplace relative to a broadcast system versus a troweled mortar and the performance criteria for which they're going to work under. And so we're going to go through a few of those and try and help you understand the differences. When you do a good specification and you try and get that out there, and you're inundated with alternatives and those sort of things, and they talk about thicknesses, and it can get really time consuming, and understanding the differences is going to be really important to make sure that the customer gets the system that they've actually specified and or have said that they really need. So broadcast system, trowel mortar, terrazzo alternatives, lots of great opportunities here for different system configurations. So let's talk about coatings first. Coatings are basically thin pieces of paper painted on your floor, 8 to 30 mils. So they're self-leveling. Anything under the substrate is going to telegraph through the coating. It's got really not much thickness. It's like painting your car, so to speak. You can, go to a more high build coating, but again, it will telegraph most of the substrate imperfections through it. You have ESD, which is static dissipative or conductive type coatings. Again, each one, when you go to static dissipative or that sort of thing, there's a lot of variables there that we really need to understand before we pick one of those, and I'll go through those a little bit later. But again, the thickness range, 8 to 30 mils, a couple sheets of paper, really, and it can be very small, just used to seal concrete, dust proof, add a shine, increase cleanability. I usually tell people coating systems can last 3 to 5 years. And I have lots that have been around a lot longer than that, and certainly, but in order to give the real performance, you want to kind of downplay what those coatings can do, because there are better systems for longer life cycle. And so as we talk about high build systems, 1 to 2 millimeters, decorative options, concrete requirements are extremely important here because they have to be completely level and fixed before the substrate you can put any of these self-levelings on. You can't have a great big slope or all your coatings are going to be running over into the corner. So you have to be very careful with this. High build systems are susceptible to temperature installations, so we can deal with pinholes. We can deal with blushing and those sorts of things that can happen during the installation. So although they seem, relatively simple, they are, difficult to repair when you get an issue. If you do a big floor like this, and all of a sudden you've got a section where there's a few pinholes or that sort of stuff, in order to repair that high build system, it's like putting a small patch in your car. It's difficult to make it blend. It can be done. But it's difficult to repair, really, to make it look perfect. And so the installation parameters, temperature, humidity, all those sort of things have to be watched carefully. So these are the kind of situations you see, lobbies, clean rooms, pharmaceutical manufacturing where there's only foot traffic. You'll notice most of these areas are very low traffic situations, warehousing, assembly. We do, quite a few car dealerships too, as well, this sort of stuff. I always tell everybody, mostly my job is to tell everybody what they need and give them the best system, and then look at what they can really afford, and then letting them understand what that difference is in terms of life cycle. So, it's important. After 30 years, I've learned to make sure that, you under promise and over deliver, and your phone's not ringing every day, which is important. So this is a very decorative system. In this particular system, the materials are put down, and we actually throw some solvent onto the surface to kind of cause that model look. So it's almost like a contaminant. We let that happen and seal it, and that's how we kind of get that decorative options. But in this case, the designer or the owner can stand beside us, and we can kind of do that together. It's very much a piece of art, and that art is really based on what you want it to look like. So it's pretty important that when you're going to do those things, that the owner is really involved and really understands, and they become part of the design. So again, this is a lot of different options as it comes to these high build coatings. When it comes to ESD or conductive systems, there's a lot of misconception in here. As soon as you put a coating system on top of a concrete floor, you're actually insulating that concrete floor. So think of that as putting a carpet across the floor. And as you walk across that floor, you build up friction and tribocharging into your body. And you touch something, it will spark. So it's not too bad on a coating, but in a lot of cases, there's a lot of areas that you might not want that to happen. Electronic equipment, you're building those. Perhaps it's solvent storage and you have explosion issues. And then when you get into that situation, is it a mechanical spark proof? So if you drop a hammer and it causes a spark, is that the kind of spark resistance you need? Or is it because you need to dissipate, electronic equipment charging? So when it comes to these conductive systems, again, it's really important to have somebody that really understands the differences and the actual target of what you're trying to do. So that these systems come both coatings, high builds, and even trowel applied mortars when you need them. One of the projects that I'd done a number of years ago was actually a missile storage facility, and that missile storage facility, there's gases around all the time, and they were really concerned about impact sparks. So they're working on it, they drop a hammer, it hits the concrete, creates a spark. Well, a system has to be pretty thick to do that, and part of the conductive flooring design in that case was plastic aggregates. So again, it's a design situation, but certainly something that we can handle if required. You're looking at some of these areas: engine test centers, computer areas, laboratories, data centers. Actually, you see the fighter jet down in the left-hand corner. I think one of our textured systems was actually developed in order to let the CF-18s have a parking spot here in Canada. And they're fancy-looking jets, but they're actually spewing a lot of chemicals and a lot of fuel all the time. And so they create quite a fire hazard if there was a spark situation. So again, a lot of the systems that you're seeing are designed because an owner needed it. Need is always the force of invention, and as the needs change, we and other companies will respond to that in an appropriate manner. So broadcast systems are the next section. So these are basically a little thicker than a coating, but not as performance-based as a trowel-applied mortar. So they're about a 1/16 to 3/16. If your substrate's in great shape, you can probably get away with one of these systems. So if you're building something new and you don't have a lot of issues with that substrate, the concrete's been poured well, it's great shape. So then these sort of broadcast systems you can get away with. So you can basically use just a primer, a broadcast, another coat, another broadcast, and a sealer. So it's pretty thin. So it doesn't, it's gonna have some great performance, but it's not going to have the longevity of a troweled flooring system. And but it does offer a alternative to a high build coating and versus a troweled system. It's kind of that middle of the road system. So we have that, in a lot of areas. And in this particular case, it's showing, a particular laboratory or chemical laboratory area where it's in the walkways and those sort of things. But again, 1/16 to 3/16, moderate durability. When you look at this broadcasting, as you see here, you see the gentleman in the picture using a broadcast machine. Now, this is really important little piece of equipment. I see people all the time, guys and the installers coming around, and they're chicken feeding the broadcast materials into the resin. They might even throw it, and the next thing you see is you're seeing marks caused by the application of the broadcast. In this particular case, this is a broadcasting piece of equipment, and we broadcast the sand to complete refusal. One of the things we always recommend is do not allow reclaiming of the broadcast material for reuse. These materials are made in a factory, the sand. They're urethane coated, they're graded, and they have zero contaminants in them. One of the things that you really would never want to have, what happens if you recycle some of those broadcasts and some sort of contaminant gets in there, and now you don't know what, you've got a weak spot in that floor. Now that floor might not show up for a number of years. So that's really important not to recycle that. As you look in here, locker rooms, light manufacturing, restrooms, you could probably get away with a broadcast system. A lot of times, depending on what that looks like, you might go with a troweled mortar, but we have tons of these, and you see these in a lot of places around in that broadcast system. So one of the things that we're seeing a lot of today is the new flake broadcast, and at first I thought this was a great addition to our product lines, and the more I see this, the worse I believe in it. These flake broadcast systems, they come in at a very similar thickness to the sand broadcast systems, but the weak point here is the flake. The flake itself offers little or no durability, so you're totally relying on the sealer material as the only defense for abrasion resistance. So these flakes, they are vinyl flakes, and they're, we're trying to make sure they're all glued down, and they certainly look nice and that sort of stuff. But I really believe, they're not highly durable over time, not compared to if you're trying to wear through a piece of sand or a quartz aggregate versus a vinyl flake. For sure that vinyl flake is going to wear quickly. So I see issues where there's, in an office or something where the chair is moving back and forth, or there's a repeated action in a certain section. But they are nice, and they can be repaired quite easily. But they're definitely a cost saving measure versus the appropriate sand broadcast or quartz aggregate broadcast. Here's some of the situations where you might see, again, a broadcast system, a classroom, maybe a hallway, a sterilization area. Like a pool deck, you would never use a flake broadcast system around a pool deck. You would have to have some sort of a broadcast system that has a texture. And that's one of the downsides of those flake systems it's very difficult to put a good texture on the surface of that, because as you add texture, you cloud the surface of the floor. Whereas in a sand broadcast system, the sand itself is the color, and the less sealer you put on, the more slip resistance that is. So, that's pretty important as it comes down to, selection. So if slip resistance is important, flake broadcast won't work. You pretty much have to move to a sand-based broadcast. So they look at alternatives to stained concrete, and we've just stained concrete's become like the flavor of the month in the last little while, and we certainly see the need for that sort of thing. And we developed, or companies have developed epoxy systems or other systems that mimic that look, but they provide a lot of more benefits. So, if you've ever been into, the large box store and you see the polished concrete and the entrance is all worn, you see aggregate, the stained concrete doesn't offer any sort of chemical resistance or UV resistance. It can be slippery and that sort of stuff. So we have a system that has the same sort of look, that lightly textured appearance, but it offers all those things that a stained concrete doesn't offer. So it's very thin surface, but it does offer that alternative to trying to go with a stained concrete. One of the things that I always like to talk about and is the ability to put a appropriate troweled coving in. As it comes to broadcast systems, as you can see in the picture here, you can see the gentleman's got a 3-component troweled mortar, and he is forming the 1-inch radius with that mortar. We see a lot of contractors taking shortcuts when it comes to this by putting resins and trying to broadcast that cove in place. They'll even just put a 45 in the corner and then broadcast up to the 4 inches. This is really the most important part of your flooring system as it comes to infectious control and cleanability. You really want to make sure that you've got a troweled cove, if that indeed is what you wanted the look to have, and make sure that that detail, such as the left-hand portion of this slide, is in the drawing or in the specification specifically, because this is an area where contractors can take a real cost-saving measure if they don't have to do this. If they can just get away with a broadcast, they're saving a lot of money. It looks the same, but from a performance point of view, it's certainly not going to perform that way over the next 15 to 20 years. So as you specify a broadcast system versus a troweled system, this is somewhere that you really want to key in on and make sure you differentiate during the specification process. As you can see here, you can see that we're, a couple of applications where you've got the coving down the side, nice coving in around all the toilets, and those sorts of things. A great cleanability, that nice 1-inch radius that allows the cleaning people to come in, the infectious control people to come in and get a great clean up on the floor. This is, to me, 30 years, I always recommend people to put coving in. You're going to love it, and it's really going to improve the performance of the floor over time. Some people like to put a rubber cove down. The rubber cove builds mold in behind it. It can build, the glue can let go, and it causes a lot of seams. Those seams are places where listeria can grow and those sorts of things, and you really don't want that happening in most areas. The nice seamless cove, certainly to me, is one of the most important design functions of a good seamless flooring system. So as I said, we've got broadcast, and now we're going to talk about troweled mortars. So those coves were really a troweled mortar. So these troweled mortars, they go in at 3/16 to 3/8, and even up to 5/8, depending on chemical resistance, impact resistance, how long the life cycle needs to be, those sorts of things. And you can build that thicknesses with your coatings consultant to the level that you might need. And you can use a number of different resins, everything from epoxies and urethanes and MMA, but also Novalax and vinyl esters and polyesters. As you need that chemical resistance change, and you can also even add different levels of fiberglass mat into the surface to increase its ability to handle thermal cycling and thermal shock. So troweled mortars, as I said, these are real floors. These are designed like the old terrazzo. They're designed for a life cycle of 20 years with very little maintenance, and performance is excellent. And certainly, this is, if you want the top-notch, troweled is always the way to go. So when you look at this, you look at a primer. So a great primer that penetrates into the concrete. It stays wet while you trowel your mortar over the top of that. Once that mortar cures, your ability to give it a grind and clean all that sort of stuff up, make the imperfections go away, and then a seal coat. That's a typical industrial type system. And then you have, this is where the commercial and industrial really come together, where we have a combination of both a mortar system and a broadcast system to give the benefit of an industrial strength floor in a commercial application. One of the ones I always talk about, if you ever want to put a floor in a prison, believe me, it's industrial. So you look at that, you go through the same process where you put a primer, you trowel a mortar down. It's a little bit thinner than the typical 1/4 inch, because once you get that done, you're going to put another layer of resin, a broadcast aggregate, and then another sealer. That allows us to make it decorative. It allows us to make the mortar system slip resistant. We can use different types of texture. A lot of people say, oh, you throw some silica sand or whatever. If you've got a lot of traffic in an area, you might want to use an emorandum as the texture, or you might want to use aluminum oxide as a texture, particularly if you really you've got heavy loads. The emorandum doesn't squish and crush. The aluminum oxide, if you really need a super slip resistant type floor, think about French fry plants or chicken processing plants or those sorts of things where slip fall issues are really important. So that all can be designed into a troweled mortar floor. And again, of course, the coving for infectious control. So this is really the pinnacle of flooring design as it comes to longevity and life cycle costs. You see here a situation. This is a manufacturing facility. It's a racking area. You see them taking up a thin film coating. And we do this all the time. Somebody comes in and tells them that, you can paint this floor and it's going to work well. Forklifts are going to drive over it. And then all of a sudden, those pallets have a nail sticking down or something, and they're scratching through the coating, and it's just not lasting. And you end up painting it like your deck outside. You got to paint it every 2 years. So the mortar system, it eliminates that. You get the mortar system in place, get that all troweled. The thickness is a 1/4 inch. That one nail scratches it. It can be touched up. So you get the longevity of the system, and you're able to do maintenance as you go along. And, I always tell everybody when I do a specification or I do something with a customer, I really own the floor forever. It's my floor as long as I'm in the business. So I really want to make sure that they understand what they're getting. And this really helps when you talk about maintenance. I plan to be back here in 5 years or 3 years or what have you. So if you look at, this is a kitchen kettle area, typical, quarry tile with the drain. And the situation is that quarry tile is seeing thermal cycling, and it's got shearing going on underneath the tile. So you can't even, the tile looks like it's intact, but there's mold growing underneath that. There's listeria opportunities. So these pots are dumping water on the floor. So we go in there with a total hygienic approach, and we look at putting coving up behind those kettles. We use a resin material that will handle 150-degree delta to handle that hot water instant shock without shearing the concrete. We even look at the drains and make sure that the steel drain is isolated from the urethane, because under high temperature, that steel and the concrete are moving at 2 different speeds. And over time, the cycles will cause cracking around the corners of those drains. So just having an engineering detail that shows the isolation of that drain. You need to talk about the thermal delta that's going to happen. So a lot of this stuff is part of the questions that we need to talk to the customer about. If you as a designer decide that you're going to be helping a hospital or maybe a hospital's kitchen, then really understanding that there could be different resins required for different areas in that kitchen. So, it's easy to just say, yeah, just give me a epoxy floor. But a good designer is going to look at that and go, well, we really have some different needs in different areas of that kitchen. And again, a good coatings consultant can really help you through that, and certainly doesn't really change the look of the floor. I could put epoxy in this section, urethane in the other, and a combination of such, and you wouldn't, by walking on the floor, even know there was a difference other than in the performance characteristics, which, if appropriately set, should have no problem whatsoever. So base mortar, a base mortar, that 1/4 inch material that we put across, it's going to cover a lot of the imperfections of the floor. At a 1/4 inch, it's going to follow the undulations. And if we had a situation that we needed to have that floor sloped a little bit more, we can use the appropriate grouting system designed to work with that resin. So if we're putting an epoxy floor, we use an epoxy grout so that the whole system works as one. The same thing with a urethane. We use a urethane grout. Again, on the thermal cycling, you want that to work as one. So the important part there is, we have a lot of people who all just put a little concrete here or a little cementitious grout. And, you really want to make sure that your whole base is designed to move as one. So this is really important. So the before and after, you see some stuff on the left, and you see on the right, it's been troweled and it all looks good. Some of the other areas, manufacturing, the safety yellow lines can be embedded in the floor, biomedical, food processing. You'll notice there the red curbs up and over a 1 or 2 foot curb. You can trowel up and over the top of that. One of my favorite installations is the beverage and brewery. We see a lot of the microbreweries going on right now, and even trying to convince them to do a proper mortared floor in the beginning of their production is really important. I've done some coatings, and a couple of years later, they go, "Yeah, we should have done what you said and gone back to replace it." But it's really important, because once that equipment's in place, you want me to get in underneath there and get a good prep and get that all done. That becomes a real issue. So decorative troweled mortar, this is what I was talking about, where you use the base mortar and then you add decorative custom patterns on top. It's really quite a great opportunity to have that industrial strength in a commercial facility. And that could be, big cafeteria areas, high traffic, concourses. I think did one in Quebec, a big one like that, all the concourse. These are areas where you want decorative, but you need to have the industrial performance. One of the greatest things that I see now that we really, is that we've come up with, or the industry's come up with, is troweled resilient urethanes. And these are going a thickness of 1/8 to 3/16. They're extremely decorative, but they've got some great ergonomics capabilities. So, standing on a concrete floor in an OR on a hard floor versus standing on one that's got some flex and give to it. So these are great new resin system that has come up with, using recycled rubber and that sort of thing to really increase the ability for a surgeon to stand there. We've also added some great coatings for iodine and that sort of stuff to resist that sort of chemicals that come out of the body or used by the surgeons. And the other thing is getting that super flat finish, so that the carts and equipment are not rolling away. So in this particular case, you can see we've taken out sheet vinyl flooring and found all the mold and stuff underneath it, and we've replaced it with that epoxy system, or in this case, a flexible urethane that is bonded intricately to the floor. So we don't have to worry about what's underneath it, because it's part of the structure. Again, some of the situations, multi-purpose rooms in schools, libraries. This also has some sound deadening capabilities as well. And that, again, is an important aspect of these types of floors that we can work with. We look at healthcare, public spaces, all of these areas. A lot of the resin systems can be designed to meet the criteria of your owner or designer based on thickness, longevity, cost benefit analysis. Again, all of these things are available with a good coatings consultant. So these elastomeric membrane systems, these are basically your waterproofing. So they're designed for mechanical rooms, tank linings, those sorts of things, and they have different properties. Again, they can come in a urethane, they can come in an epoxy, they can also come in different resins, but basically they're 10 to 125 mils, and they provide, positive side waterproofing. If you're doing washrooms in a second, third, fourth floor of a hospital, you might want to be putting some elastomeric membranes under your floor. just to make sure if the building moves and it gets a small crack in the concrete, that doesn't transmit through to the flooring system and cause any leaks. In some situations like this, you see, hotel outdoor areas, outdoor pool bars, resorts, those sorts of things. A lot of our systems are systems that of resinous background that can now be used outside. We've come a long way in building in UV resistance with some really tight urethane technology. So there's a lot of opportunity here for us and other companies to help in the design of these outdoor parks and really put in slip resistance and UV resistance and those sorts of things into your design. From a positive side, waterproofing, in a mechanical room, we look at this sort of stuff so we can, maybe a little bit thinner. We add a broadcast if you need some texture resistance, but it's, low maintenance and certainly offers that kind of protection. We can make it decorative if we needed to, but that positive side, waterproofing, pretty standard industry stuff, but certainly something we can help with. When you look at traffic bearing membranes, it's basically that flexible membrane we're talking about, but we're needed to be able to handle cars. So we increase the thickness, we change it a little bit in terms of resins, we put texture in it, we do all kinds of parking garages, helipads, pedestrian bridges. We can add texture to it for slip resistance and then have to provide UV resistance. You've all been in those parking garages where it looks wonderful with all the lines, and then, a couple of years later, it's pretty much, void of any color. It's all been, the UV's got, killed it. So these are all changes, but traffic bearing membrane, certainly part of the kind of a high build coating positive side waterproofer. Concourse here, I don't know this picture, but as you can see in this particular case, this is all the concourse is done. We do, a lot of times we'll even do where the chairs are with a coating, like just a regular epoxy, just to make it cleanable and put textures and nose guards on the fronts of the stairs so it's anti-slip. Again, these are the parking garages, hotel entrances, stadiums, helipads. Again, most places where you really need to have some waterproofing and or some, cleanability with your design criteria. High performance wall systems. I mean, anytime you get into a high performance wall system, you're using similar resins to the floor, and depending on the substrate of the wall and what you're trying to achieve, the systems can be 10 to 25 mils. They can go over concrete block. They could go over drywall, concrete board, plywood, all kinds of different surfaces, and just thicknesses and flexibility and impact resistant changes based on which one of these systems or resin systems meets the criteria. So you can look at a nice patching compound to round out the edges of the corners. You can reinforce it with fiberglass to increase the strength on the surface. For example, if you were going over drywall and you wanted to have a pretty high performance paint system, you could add a fiberglass reinforced epoxy on the surface of that to really increase the chemical resist or the impact resistance and keeping the substrate cost low. But if you wanted to have a more durable one, you can increase to a block system and make that look just as nice using patching mortars. So those substrates, as I said, concrete block, wallboard, cement board, even plywood, you can make look good with some of the resins that we use on the floors. This one of the biggest things that we talk about is making sure you get a successful installation. It's really important is watching that installation. You can make a great product in the lab, but if you can't get it installed properly, it's not worth much. So concrete preparation always has to have a mechanical preparation. Abrasive shot blast is by far the most important. You can use grinding and that sort of stuff if required, and even scarifying, but even in brand new concrete, you must have a mechanical preparation. You have to worry about osmotic or moisture pressure. We do a number of different tests. In this case, you see a calcium chloride test, a pressure test, and even a plastic vinyl test. And we look at all those to determine what that looks like before an installation. And certainly that's an important test if you have a slab on grade. So you always want to make sure you've got a vapor barrier and that sort of thing in place when you're going to be putting on a seamless floor. That osmotic pressure mitigation, we have a number of systems that can work on the surface of the floor to protect against that. It can reduce 15 pounds to less than 3 pounds so that we can actually put a seamless floor on that. So again, there are systems available for that, and that can be used in cases where perhaps a retrofit and there's got some issues that can't be fixed under the slab. Here's some of the engineering details we really look at, which is really important. The transition to existing floors by chasing the material, so you don't want to feather it out. You want a thick edge. Crack treatment to bridge cracks that could be underneath the mortar to make sure that they don't transmit through to the floor. As I mentioned before, around the drains, putting that caulking around the drains so that the two systems can move independently. And then, of course, the actual control joints and that sort of stuff. So these termination details, as I said, around drains, very important, chasing that out. Crack treatment, again, you got some structural cracks. Your coating consultant can help you with that and come up with the appropriate crack treatment. Application and installation, this is the guys doing the applying the mortar base. You see a screed box to make sure it goes down at the right level, and then the power trowel and or hand trowel installing the mortar. You can see the hand trowel. Those guys. Once that's done, we get the grinders out and clean up all the edges and that sort of stuff and grind it smooth. And then we look at all our expansion joints. So once the floor has been in place, we saw cut those or preform them depending on what we need to do. Again, it's decided with the designer and the owner on which ones we have to really pay attention to. Control joints are different than expansion and isolation. Again, I'm there. We can talk about that if anybody's got some questions. And the coating, finish up the coating after it's all been ground, and we can put different improved cleanability, chemical resistance, modify the texture in this step. Pigmented, we can go with urethanes, flat, gloss, satin, all to finish that floor off as in an appearance point of view from what the customer really needs. And then the biggest important area is specifying for installation success is experience. Make sure the warranty is good, references, whether or not they can have on-site technical support and service and follow-up. This is the core for us at Stonehard. We look after it one way, right from the start to the finish, and certainly something that happy to help anybody with, and certainly something that I built 30 years on. So as we finish this up, certainly this is my first virtual meeting. I'm happy to take any questions. We have questions, in the past, like, can you do custom colors? Of course you can do custom colors. Can you put it in a freezer? Absolutely, you can put it in a freezer. These are the sorts of things that we can answer as coating consultants. We can talk about costs per square foot and those sorts of things, but really reaching out to a solid coating consultant is going to really help you. And I'd like to thank everybody for paying attention today. Hopefully that presentation went okay. I'm used to live feedback, so getting questions would really help. But anyhow, thank you so much for tuning in today, and hopefully we'll get some questions, and that will wrap up for our Resinous floor and wall system presentation.